This is lesson number 2. We're still in systems. Today we're going to talk about the inequality portion of this unit before we go on to more problems and things like that coming up. So there's a couple of things. We did this not too long ago when we had graphing one inequality. The same thing applies. Less than or greater than is simply dotted line. If it's got an equal to attached to it, it's a solid line. And again, we're going to use a test point, see which side to shade on both inequalities you're going to have. So dotted line, solid line, we've got a shade. We're still going to graph the same way, standard form or slope-intercept form, whatever way we have. We only have 2 examples here. The first one is this graph. We have y greater than or equal to 2x minus 3. We also have x plus y less than 4. So we're going to graph both of these inequalities here, and we will see what we come up with. We have our graph ready to go. We're going to go in 2 different colors here. That way we can tell the difference. That's probably a suggestion for you when you get on your own. Go black, go blue, pencil, pen, stuff like that, whatever. With this first one, y greater than or equal to 2x minus 3. Now notice our symbol, it's got an equal to, so we can figure out it's going to be a solid line. So we're going to just write that in, just based on the symbol that we have. This is in slope-intercept form. So the -3 here, that's your y-intercept. Y-intercept at -3. Number before the x, that's your slope. So your slope is 2. Again, if it's not a fraction, we're going to make it 1. So I'm going to call this 2 over 1. And since they're both positive, what I'm going to do is go up and to the right. Remember, you always got the alternative to go backwards, or kind of almost like a reverse thing, and go down and left. It will still work the same way. So y-intercept at -3. Well, again, we're not supposed to make points, but we about have to get the line. So we got 1 at -3. We're going to go up 2 to the right 1. That's going to get a slope, and I'm going to do it again just for drill. Up to right 1. Okay, so we know it's a solid line. And that's not very good. Okay, that's better. So we have that line here. We're going to do a test point. So we're going to test this out. Test point at 0, 0. See if this works, which side we need to shade on. If we plug this in, we're going to get 0 greater than or equal to 2 times 0 minus 3. Once you work it out, you're going to get 0 greater than or equal to, this is 2 times 0 is 0, minus 3. So 0 is 0 greater than or equal to -3. Well, that's a true statement. So here's where 0, 0 is at. So we would shade on this line. Now, I'm not going to do much here. I'm just going to put some lines like this, because I don't want to go crazy, because I got to shade twice, and then where it overlaps in your shading is going to be your answer. So that's the first inequality to graph. Second inequality we have here, x plus y less than 4. If we look at our symbol, we know it's got to be a dotted line here, because it is just less than. So that's another key piece to the puzzle here. This is in standard form, so I'm just going to use the intercepts here. So if I cover up y, my x-intercept is 4. So again, that's my x-intercept. I cover up y. And then the same thing is going to apply for when I solve for y. If I cover up my x, I'd have y equal to 4. Again, these are two different points. One's on my x-axis, one's on my y-axis. So x is 4, y is 4. Okay? We're going to have this. That was just terrible. Okay, we're going to try to draw this. Alright, it's not great, but it works. It's close enough to the blues, I guess. Whatever, sure. Test point here, we're still going to do the same thing. Once I get back to the blue, there we go. Test point, 0, 0, because it's not on the actual line you've graphed, or inequality you've graphed. So 0, 0. We plug that in, we would have 0 plus 0 less than 4. Obviously 0 is less than 4, so we have another true statement. So here's where 0, 0 is at. We're going to shade on this half of the dotted line. So once we've got that, where it intersects at is the actual answer. This region here is the part that's the actual answer. I could get rid of all this. Now, you don't have to erase it. I'm just showing you what you're actually going to have come up with. So that's what we end up with. You graph two inequalities, check your lines, check your shading. Where it overlaps, that's going to be your answer. So that's the first example, and then we have only one more to go. All right, our last example, the dreaded story problems. Tony wants to use $200 he earned to buy some concert tickets for himself and some friends. Well, how nice of him. He wants to buy no more than 8 concert tickets. Lower level ones cost $35, upper levels cost $20. And we need to write the system of inequalities to model this. All we're wanting to do is just get the inequalities written, although we'll explain how to graph it as well. So we're going to take a few second break, just kind of comprehend everything, and I can get things set up. All right, we've done some labeling here. We're going to call L for lower level, U for upper level. You can go X, Y, it doesn't really matter. I'm just trying to be different, I guess. All right, everything has been highlighted into what goes with what. Money goes with money. This is its whole separate equation. So what I'm going to do, we're going to get both equations at the same time here. So let's go here. We know that lower levels cost $35, so let's attach that. 35L, $35 per ticket, lower level ticket, plus the $20 per upper level ticket we're going to have, plus the 20U. Now, you know you cannot go more than $200, but you could spend every cent of it. So we're looking at a less than or equal to 200. Because that's how much money you have. You can't go more than that, but you could spend every cent of it if you have to. Okay? Now, the second part, you can't get more than 8 tickets. So the amount of lower levels you could buy plus the amount of upper levels you could buy can't go more than 8. So that's another less than or equal to. You could get 8, you could go less than, but he doesn't want to go anymore. So that's where that part comes in. So those would be your two inequalities. Now for this example only, that's all you would need to do. However, we're going to show what the graph of this would look like just, well, because I can't. So hang on a minute. Now we move this to a new page. We've got a graph here. This will be my L axis. This would be my U axis, I guess. Let me label that. Now, both of these are in standard form, so we would find things using the intercepts. So if we wanted to go with L here, I would cover up the U part and then solve. So I would have 35L equal to 200. 35L equal to 200. Solve for that, divide by 35. Like so. Now when you do this, you're going to get a wild little decimal here. It's about 5.71, all the way. It will repeat for a while. So I'm just going to go somewhere in between about 5 and 6, a little more than half, somewhere in there. I'm going to make a point. Okay, so we found L. Let's find U. Let's find U. Make sure we got that going. So we cover up the L. We solve for the U here. So we're going to have 20U equal to 200. And then once we solve here, we divide both sides by 20. And then we end up with U being equal to 10. So find your U axis. That's the vertical axis this time. We're going to make a mark at 10. Line. Pretty good there. Solid line because it's equal to. Now, obviously, it has to be less than 200. So if we plug in our test point as 0, 0, you'd still get 0. It'd be a true statement. So we're just going to do a quick little this because we got a second inequality to come. All right, now if we want to find our second inequality, same thing as we did before. Okay, that's not going to do that. We cover up the U and solve for L. Oh, let's have some fun with this. How funny. Okay, I'm playing around now. So L would be 8. So you find the L axis, that's the horizontal axis, make a mark at 8. And then you would do the same thing and find your U. Cover it up with a nice little star. U is 8. So we go there. U is 8. Make a mark there. We're going to make a new line here. Holy cow, don't want to make a huge line there. This line. It's the same thing as before. If we plug in 0, 0, it's a true statement. So we're looking to shade everything below this line. So in fact, where they both overlap is going to be this region right here. Now, a lot of problems you'll see later, you'll have more to it, but we'll get to those when we get to it. That's just how you graph it. That's just a little extra part. You don't need to really do that according to the example. So, but you will eventually. That is the solving pairs of inequalities. There's going to be more stuff coming up, some review stuff, some ECA review stuff, things like that. So we'll get to that eventually. There you go. And this is lesson 2, and I'm signing off.